Have you ever experienced a moment where you looked at a friend and all of a sudden they looked like a stranger? There's a name for that. And no, we can't explain it. Add in silk hinges, precognition, retrocognition, and something called choice blindness, and you've got far too many unexplainable things scientists still can't crack. Interested? Well, hit that like button and subscribe so I can keep bringing you lists like this. Let's get into it, because I'm Mike with List 25, and these are unsolved mysteries that haunt modern science. Einstein, who is arguably one of the smartest men to ever exist, once called the cosmological constant his biggest blunder. Except it wasn't a blunder at all. It turned out to be true. Still, it remains one of the biggest mysteries in physics. The cosmological constant pertains to the energy of empty space. And by empty space, I mean space that isn't exactly empty. Are you confused? Yeah, me too. So, let's dive into this a bit. Here's the problem in simple terms. Space isn't really empty. Even in a total vacuum, there are blips of energy flickering in and out, much like a candle. If we add all those blips up, physics says space should be overflowing with energy. When astronauts measure exactly how the universe is expanding, the amount of energy in space is tiny, which is quite the contradiction. Is this simply a case of two things being true at the same time? Maybe, but the math isn't mathing, which is the biggest problem. The universe is expanding, but the energy that drives the expansion is smaller than predicted. Make sense? No, of course it doesn't. This is just one of those mysteries where it is what it is until someone can finally prove otherwise. Want to play a game? Oh, sure you do. Imagine yourself spinning around in space with a giant camera. You point left, you point right, up, down, all over the place. And the universe looks the same from every single direction. Weird, right? Yeah, it is. Galaxies are spread out evenly, and the leftover glow from the Big Bang basically keeps everything everywhere at the same temperature. In theory, parts of the universe are so far apart, they never have a chance to connect to each other. But they look so similar that it's like having two people show up at the same party in the same outfit. It's an odd cosmic connection that makes it seem like it's all very coordinated. Even here on Earth, no matter where you are in the world, when you look at the sky, everything is strangely uniform. This puzzler is known as the horizon problem, and it's one of the big clues that led scientists to the theory of cosmic inflation. So yes, the universe looks the same in all directions because something wild happened in the earliest moments that made it look like it's a replica of itself over and over again. What makes up about 70% of our universe? It's not stars, it's not comics, it's dark energy. Not spooky, right? It's not as dark as it sounds. It's just the term scientists use to call the invisible something that makes the universe expand faster and faster. Back in 1990, astronomers studying supernovae expected to see galaxies spreading across the universe, since gravity should be pulling everything back together. But no, that's not what was happening. Instead, those galaxies were on a cosmic sprint away from each other at an accelerating pace. It was a complete and total shock. The unknown force that fills space and pushes all the galaxies apart then became known as dark energy. We still don't know exactly what it is, but at least we can see what it does. This is a doozy that has stumped scientists since Einstein discovered gravity and quantum mechanics. How can two things be real and true but also completely contradict each other? Think of it like two geniuses who completely disagree on everything, but they're both right in their own way. Einstein proved gravity isn't just some invisible force pulling things down. It's actually space and time bending around large objects. Hence why planets orbit stars and why black holes are such beasts. For quantum mechanics, however, things don't run as smoothly. It's the rebel of physics and lives in the world of teeny tiny particles. Those particles are jumpy and weird and completely unpredictable. Instead of dealing in definitives, quantum physics deals solely in probabilities. Quantum physics ties things like electromagnetism and the forces inside atoms together with a pretty bow. In theory, anyway. Gravity refuses to fit in, though. And when these theories are put in extreme situations together, they break down. To this day, scientists are still trying to find the ultimate theory of everything that'll finally marry Einstein's universe and the quantum world. Let's go back to black holes for a minute. You know, that cosmic vacuum cleaner where once you're sucked in, you never get out. You'd think it's just a giant pit of nothingness. But no, it's not like that at all. Black holes not only have a temperature, but also entropy. This discovery completely changed everything we thought we knew about the universe. While temperature is just that, measuring how hot it is, entropy is basically a measure of disorder, or how much information is packed in. In the 70s, physicists began noticing black holes were playing by rules that were eerily similar to the laws of thermodynamics. Jacob Bekenstein was the first to jump in on this idea when he realized the way black holes were behaving. He theorized that black holes have entropy, but not the way people or science itself would expect. For the rest of the universe, entropy is tied to volume, but for black holes, it's tied to surface area. This realization shook up the physics and began to bridge the connections between gravity, thermodynamics, and quantum physics. We've all experienced déjà vu before. That weird moment when you walk into a place or hear a phrase and all of a sudden it feels like you've experienced that moment before. Now, jamais vu is basically the exact opposite. It's when something is 100% familiar, but it suddenly feels brand new. For example, you could be having a chat with a friend and suddenly their face looks like that of a stranger. Or you walk into your office and it feels like you've never set foot in there in your life. The term itself means never seen in French, and scientists have been scratching their heads over this one for years. One explanation is that the brain's memory circuits briefly fall out of sync. The information is there, but the recognition system kind of falls behind, so everything familiar suddenly feels foreign. Another theory says it's more about your level of attention. When your focus slips, your brain effectively re-registers whatever you're seeing as if it's brand new. Whatever the cause, we're still trying to figure it out. If jamais vu is disturbing, presque vu is 100% annoying. It's that crazy tip of the tongue moment when you know exactly what you're trying to say, but the word disappears or just won't come out. You can picture it, you can almost feel it, but it stays just out of reach. Hence its name, French for almost seen. It happens to over 90% of us, so it's actually crazy that we don't have more scientists studying it. Psychologists think it happens because your brain thinks of a similar wrong word first, like momentum instead of momentary, and that basically jams the system. What we do know is that the more you panic about it, the worse it gets, which is why the best thing is to just let it go. Odds are you'll remember the word a few hours later while you're busy with something completely unrelated. On rare occasions, cancer seems to break its own rules. A tumor that once looked unstoppable suddenly shrinks or disappears without any therapy. This phenomenon is called spontaneous regression, and we've been trying to find its mechanism for ages. One angle researchers are exploring is fasting. Some case studies have shown that tumors get smaller after prolonged fasting or dramatic diet changes. The idea is that fasting kicks off a process called autophagy, basically a cellular cleanup mode that clears damaged cells and pushes the body to renew healthier ones. It could also boil down to fuel. Starve the body of glucose or insulin, and you may also be starving the tumor. Still, that doesn't explain why spontaneous regression is so rare, or how the body decides when to fight back. Zombie fires are exactly what they sound like. Fires that seem to come back from the grave. And not just anywhere. I'm talking about the Arctic, especially in Alaska, Canada, and Siberia, often appearing in early May when the snow melts. The peculiar part is that some of these fires appear to be the same fires from the previous summer, which just smoldered underground through the winter for a couple of months. As you can imagine, there are several theories about how it happens, but scientists can't seem to find a consensus. According to the main theory, peat, which is dense and packed with carbon, burns quietly below the surface for months, insulating itself from heat and moisture until warmer, drier conditions reignite it. In 2021, satellite data actually confirmed that a lot of these fires started up where the previous seemed to end. However, other researchers believe that the warmer air temperatures may heat the ground enough to spark new ignition events in the spring, which only creates the illusion of old fires coming back to life. NGC 247 is a spiral galaxy about 11 million light-years away, and it's famous for something astronomers call the void. One side of the galaxy is full of stars, but the other side looks like someone punched a hole through it. At first, scientists thought the gap might have been caused by gravity tugging from a neighboring galaxy. Later, some suggested it could even be the result of a past collision with dark matter, which would have disrupted gas clouds and shut down star birth in that region. Of course, the idea that caught most of the public's imagination came from SETI enthusiasts, who speculated that it could be the work of extraterrestrials building massive Dyson spheres, energy harvesting structures that surround stars. But it kind of goes without saying that that is 100% speculation. The truth is that the void's origin is still up in the air. Or up in space. There's no air in space. In 1989, two chemists, Stanley Pons and Martin Fleischmann, stunned everyone by announcing they'd pulled off nuclear fusion at room temperature using palladium electrodes and heavy water, so-called cold fusion. Now, if everything sciencey gives you a headache, let me just say that I'm talking about the same reaction that powers the sun, but happening in a tabletop setup. If they actually got it to work, it could have meant practically unlimited clean energy. The catch was that nobody else could recreate it. Most scientists chalked it up to error, and the claim was quickly dismissed. But here's where it gets interesting. Other researchers started noticing that similar experiments with palladium in heavy water sometimes gave off bursts of heat or even left traces of nuclear byproducts. And labs in Japan, Italy, and the US have all reported odd results over the years, which is why cold fusion has never fully disappeared. None of it fits with what physical science said should be possible, and yet some people argue it was dismissed too quickly, pointing out that entire industries would have had everything to lose if it actually worked. Still on the topic of black holes, let's talk about the biggest cosmic mystery surrounding them. What happens to information when it falls into one? The question is simple to ask, but insanely tricky to answer. Does the information that goes into the black hole paradox vanish? Does it get erased forever? Or is it still out there somewhere? In Einstein's theory of general relativity, black holes are basically giant cosmic paper shredders. Toss in a star, a planet, or your term paper, and it'll seemingly vanish. All that's left behind are the black hole's mass, its electric charge, and its ability to spin. As if Einstein's theory wasn't wild enough, in walks Stephen Hawking, or Rolls, who later discovered black holes aren't black at all. They slowly evaporated by releasing Hawking radiation. Yes, it was named after him. Yes, he deserves it. And yes, everyone in the science community misses his big, beautiful brain. Alright, back to what I was talking about. This is where the paradox comes in. Quantum mechanics rules state information can never be destroyed, and the universe keeps track of everything in some form or fashion. If black holes really do erase info, it breaks that rule. It's quite the quandary, and scientists still struggle with this puzzle today. If anyone ever does find the answer, it could very well change everything we know about the universe. Did the universe go through a growth spurt after it was born? If we believe the inflation theory, then yes, it did. And not just any growth spurt, but one that was bigger and faster than anyone could ever imagine. Scientists believe a fraction of a second after the Big Bang, the universe ballooned in size and expanded faster than the speed of light. Could it be that space, as we know it, went from the size of an atom to the size of the galaxy in the blink of an eye? It very well could have. Without the inflation theory, our universe doesn't make sense. Inflation explains why the universe looks flat instead of curved or warped, and why everything looks the same no matter what direction you look at it. It also removes some leftover questions from earlier physics. Here's another big question that scientists have yet to figure out, and one that keeps way too many people up at night. Why does anything exist at all? Physicists believe the answer lies in something called baryogenesis, which in layman's terms means that in the very early universe, some special process gave matter an edge over antimatter. It was Andrei Sakharov who figured out what conditions would have made this all possible. This theory is 3 parts. First, he looked at how the rules of physics allowed particles like protons and neutrons to change. Second, he took into account that matter and antimatter did not behave like perfect mirror opposites, which meant there had to be a small difference in the way the laws of physics treated them. And lastly, he looked at how the universe could not stay in perfect thermal balance, because if things were too uniform, those differences would just cancel out. When he put all that together, he got the recipe for how the universe has more matter than antimatter. And that sliver extra is what built the galaxies, stars, and planets. In other words, you're here today because, in the cosmic coin toss, matter managed to cheat just enough to stick around. Here's a strange fact about the building blocks of matter. Nature didn't just make one set of particles to build everything around us, it made 3. Think of it like buying one phone, then finding out you've also got 2 heavier, fancier versions in the box that you actually never need to make calls. These are called generations of particles. The first is the stuff we're made of: electrons, quarks, and down quarks. Those are what build atoms, molecules, and nearly everything in chemistry. For some reason, though, there are 2 more copies of this pattern at higher energies. These cousins are called muon and tau, and they're heavier. The quarks also have bulkier relatives. These particles don't hang around everyday matter. They decay quickly, but they definitely exist. That all said, we have no idea why nature bothered making these extra copies. They don't seem necessary for the existence of stars, planets, or even us. Yet they're really important for certain exotic processes, which might explain why matter survived the Big Bang, and neutrino oscillations, where neutrinos switch identities mid-flight. Some scientists believe the 3 generations might come from deeper symmetries in physics, or maybe from something wild like string theory. But for now, it's still a cosmic mystery. So the universe is basically running on one set of particles, but it keeps the deluxe editions tucked away in the background. Just enough to remind us that nature is full of surprises. A grand unified theory, or GUT, is the idea that 3 of nature's forces, electromagnetism, strong force, and weak force, were just once one single superforce. Right after the Big Bang, when the universe was insanely hot and dense, they were unified. As things cooled, they split into the separate forces we see today. Think of it like a milkshake that later separates into different layers. At first, it's all blended together, but give it time, and the parts drift apart. If true, this theory could explain why particles always seem to have neat, balanced charges, and why the forces have the strength they do. Some versions even predict protons will one day decay, though no one's seen that happen yet. Scientists haven't cracked the code, but if they do, it could reveal the hidden blueprint showing how the universe's forces all fit together. Pendulums aren't exactly the most exciting things to watch. They usually just swing to and fro, in the same rhythm, all the time. But in 1954, French physicist Maurice Allais watched his Foucault pendulum suddenly drift off its usual swing path during a solar eclipse, almost as if something invisible had tugged on it. And since that day, scientists have hauled out their pendulums and gravimeters for other eclipses, waiting for the same odd behavior. Sometimes they see the drift, other times they don't, which only makes it more confusing. According to physics, an eclipse shouldn't cause gravity or motion to suddenly change. Yet, Allais' little wobble keeps showing up just often enough to stop everyone from completely writing it off. When you stare at a blank wall or floor long enough, you'll eventually notice patterns, colors, or even images that don't exist. Your brain is wired to process input constantly, so when there's nothing new coming in, it just makes something up. It's known as the Ganzfeld effect, and the results can feel a lot like what people report on psychedelics. Some people see swirling colors. Others swear they see shapes or even faces that start to appear. At one point, parapsychologists even thought it might help prove psychic powers, but mainstream science didn't exactly line up behind that idea. What they did agree on was simple. The visions people see are genuine, but why they're so vivid and why different people see different things remains one of the stranger gaps in our understanding of perception. People have reported hearing meteors at the exact moment they flash across the sky, not minutes later or after the boom, right then. And what they're describing isn't like an explosion, it's more of a hiss or a faint sizzle. That shouldn't be possible. Sound travels slower than light, so if a meteor streaks by dozens of miles up, any real noise from it shouldn't reach you for a good while. Scientists think it's got something to do with very low frequency electromagnetic waves. When a meteor burns through the upper atmosphere, it might emit these waves, which travel at the speed of light and interact with nearby materials like glass, hair, or dry leaves, turning them into tiny speakers. Lab experiments have recreated the effect, but we're still missing the full picture. Let's say you choose something, chocolate over vanilla, photo A over photo B. You feel good about that choice. Now, what if someone swaps it behind your back and you not only fail to notice, but confidently explain why you picked the new option? Choice blindness can be replicated in any lab. In fact, in one of the most famous studies, people were shown two faces and asked to choose the one they found more attractive. After they made their pick, the researchers secretly switched the photos. Most of the participants didn't notice. They just started defending the choice they never made. What researchers still can't explain is why we catch the swap when it's something personal or really important like a wedding dress, but let smaller choices slide without a fight. Are we safe in the universe? Or could it just go poof and disappear one day? Well, that depends on the Higgs field. This invisible field gives particles their mass, and when scientists looked at the Higgs boson and that particle called a top quark, they believed our universe probably isn't in a perfectly stable state. It seems okay now, but it won't be unshakable forever. If this were to change, a bubble of true vacuum could form and expand at nearly the speed of light, wiping out galaxies, stars, and planets, hitting the ultimate cosmic reset button. It's pretty dramatic, right? Well, here's the comforting part. If this does happen, it would take way longer than the current age of the universe. So for all practical purposes, we are safe, and the universe is sticking around long enough for us to enjoy it. Is life out there? Or is Earth just a lonely little rock? The truth is, we don't know, but the odds look pretty interesting. There are hundreds of billions of galaxies, each with billions of stars, and lots of those stars have planets in the Goldilocks zone, where it's not too hot, not too cold, and water could exist. We've even spotted organic molecules, which are the building blocks of life, floating around in space and hitching rides on comets. There is a catch, though. The only thing we have proven is that Earth is alive, and we just don't know about other planets. We don't have proof that any other planet has what it takes to be livable or even remotely habitable. We haven't spotted even the hint of green people or interstellar civilizations. Yet. Scientists use mathematical probabilities like the Drake equation to make educated guesses about intelligent life, but it's all a big cosmic mystery. Life truly could be anywhere, and it's unlikely that we are a rare miracle. For those hoping there are aliens out there, you have plenty of reasons to be optimistic. We just may not know about them within our lifetime, though. Have you ever wondered why the universe follows the same kind of rules, at least in theory? Well, the answer lies in gauge theories. These forces exist because nature has certain symmetries that have to work everywhere. Yes, everywhere, at every point in space and time. When scientists use these rules, the math gives us particles that carry the forces. Photons for light and electromagnetism, W and Z bosons for the weak forces, and gluons for the strong ones. This is nature's way of pushing for consistency while also being completely inconsistent. We don't fully know why the universe is built this way, but it might just be that only forces that follow these symmetry rules are mathematically stable and can exist without breaking the laws of physics. In a way, gauge theories aren't just a neat little party trick, they're the universe's way of keeping things tidy and consistent. Have you ever laid in bed at night and wondered where space-time comes from? Yeah, me too. No, I don't have the answer. But I do have the closest thing. A complicated explanation to tell you all the reasons why we don't know why it exists. Yay! It's one of physics' biggest mysteries. Space-time is the stage where everything in the universe happens, from planets orbiting stars to light zipping across the galaxy. General relativity treats space-time as smooth and continuous. However, quantum theory shows that it might actually come from something so fundamental we don't even understand it yet. The standard Big Bang theory suggests space-time starts at a singularity, a point of infinite density and curvature. There's a catch, of course, because with space, there's always a catch. When we reach that point, the math of general relativity completely falls apart, and nothing can explain exactly why space-time exists. So, there you have it. We have no idea. None. Nada. Maybe one day some genius will come along and finally solve this doozy. On the topic of time, are you aware that time is different in space? Yeah, but why is time so different from space? At first glance, Einstein's relativity tells us that space and time are part of the same thing. Space-time, like I just talked about. But they're not exactly twins. Time behaves differently in the equations of physics, giving it a special role that space doesn't have. This difference is what lets us have cause and effect. Events happen in a particular order, and the speed of light sets a limit on what can influence what. Unlike space, which stretches in all directions without a preferred path, time has a clear direction. Entropy always increases, which gives us the arrow of time we experience in everyday life. Why time is fundamentally different from space is still a deep mystery in physics. It sits at the crossroads of relativity and quantum mechanics. Even with all our equations, nature keeps a little secret about why time marches forward while space just stretches. Have you ever known about something before it happened? There are thousands of people out there who swear they've predicted something before it came to be. A plane crash, a phone call, a global disaster that showed up in a dream days earlier. For example, some have claimed they sensed the World Trade Center attacks before they happened, describing vivid dreams or an unshakable feeling of dread in the days leading up to September 11th. The term for it is precognition, and its biggest problem is simple. It breaks the rule of cause and effect. If something hasn't happened yet, how can your brain respond to it? Most researchers blame it on memory errors, subconscious pattern recognition, or plain coincidence. In short, your brain connects dots that were never meant to go together. Even so, the stories keep coming, and science hasn't managed to close the book on it. Precognition also seems to have a mirror twin. People who say they saw an event from the past, something they never lived through, never studied, and never had any access to. Instead of seeing what's coming, you somehow see what's already happened. One of the most famous events people like to refer to is the 1901 Moberly-Jourdain incident. Two Englishwomen, Charlotte Moberly and Eleanor Jourdain, said they were walking through the gardens at Versailles when everything suddenly shifted. They described unfamiliar buildings, people in centuries-old clothing, and a bizarre stillness in the air. Later, they claimed that what they saw matched a map from 1783. Skeptics think they either filled in the blanks from memory or had already absorbed the history without realizing it. Unfortunately, there's no reliable way to test retrocognition at all. A weird hum on the Isle of Lewis in the Outer Hebrides has been driving people up the wall. It's a low, constant sound that seems to hang in the air. Not everyone hears it, but for the 200 or so residents who do, it's relentless. Some say it keeps them from sleeping. Others report dizziness, headaches, or a fluttering in their ears that won't stop. The hum registers at 50 hertz and tends to be the strongest along the East Coast. People have tried to trace it for years and even tried linking it to cargo ships, generators, submarines, and a local sewing plant. Another person described it as what they imagine the Earth would sound like if it made noise while turning. As of 2025, locals say it's only getting louder, and no one, not scientists, engineers, nor the government, has been able to pinpoint where it's coming from. In 2013, scientists in eastern Peru started noticing peculiar little silk structures popping up on tree trunks and leaves. At first glance, it looked similar to a bottle cap. But when scientists actually stopped to look, the layout didn't match anything they'd seen before. Each one had a tall central cone, surrounded by evenly spaced pillars. It looked like a miniature Stonehenge made out of spider silk. By 2019, entomologist Phil Torres had captured the video of one up close. The detail was stunning, but it still didn't answer any of the big questions. No one knows which spider builds these things, and no one has ever caught one in the act. It could be some kind of protection for an egg sac, but until someone sees it happen, well, that's just a guess. Shout out to Phil Torres from Expedition X. What's up, buddy? Totally know you're watching. Actually gotta watch that show when I'm done recording here. If you haven't seen Expedition X or Expedition Unknown with Josh Gates, highly recommend both. In May 2023, islanders on the Danish island of Bornholm felt an earthquake strong enough to rattle their furniture. But when geologists reviewed the data, they found no signs of seismic activity. The ground moved, but science had nothing to show for it. Around the same time, more tremors were also reported across southern Sweden. And while a minor blast did take place in Poland that same day, the timeline between the two events didn't line up. You'd think that was strange enough, but it wasn't the first time this has happened. In 2018, seismic monitors picked up a ripple of waves that stretched from the coast of Mayotte to Hawaii. The signal lasted 20 minutes and circled the globe. No one felt a thing. Scientists are still reviewing the data, but the cause behind those movements remains unknown. Let's make this even more complicated. Let's talk about why our universe has 4 dimensions. There are 3 dimensions of space and 1 dimension of time. Or at least, that's what observations, physics, and math tell us. But why it's 4 is a complete mystery. The number of dimensions isn't random. To have stable atoms or the chemistry to create life, you can't have fewer than 3 spatial dimensions. If there are more than 3 forces like gravity and electromagnetism, everything would act way differently. Planets, orbits, and even chemistry would collapse. 4 dimensions seem to be the sweet spot that allows a stable universe that can support life. While we do understand why 4 dimensions work, the reason why the universe is using 4 dimensions instead of 3 is still baffling scientists. It's like we've been handed a perfectly designed stage for the universe, but no one told us why it has 4 sides. The age-old question that has plagued humanity since the beginning of time is how the universe came to be, and where's it heading? Most scientists agree that it all began with the Big Bang over 13 billion years ago. And when they say Big Bang, it wasn't the sensational explosion most people picture. It's thought to be more like space itself, rapidly expanding. Once in existence, it grew insanely fast and then rapidly cooled down enough to form all the particles, atoms, galaxies, and stars we see today. As for its future, well, that depends a lot on dark energy. If that mysterious force driving the universe's expansion stays constant, the universe will keep stretching forever, leading to what scientists call a big freeze, and galaxies will begin to drift apart and stars will slowly burn out. If that dark energy changes, we may face the big crunch and the universe collapses. Or even scarier, a big rip that tears it all apart. Basically, we've got a good idea of where it came from and where it might be going, but the universe still keeps a few secrets up its sleeves. Let's get into space-time and what exotic features it has. In theory, it's like a bendy, stretchy fabric that can do some truly unhinged things. Einstein was the first to come up with the idea that space-time can twist, bend, and even knot itself in some pretty wild ways. Just think about how black holes and wormholes work. We have cosmic strings and domain walls, so to speak. These leftover wrinkles from the universe's earliest moments are just one of the many mysteries scientists keep predicting. And if you really want to blow your own mind, look into his other math equations. Some of Einstein's solutions even allow for closed loops in time. Yes, that does mean we have the potential to make time machines, though don't start building one just yet. On top of that, when we zoom in super close, down to the tiniest scales where quantum mechanics rules, space-time might not be smooth at all. It could be grainy, foamy, or made up of discrete building blocks, kind of like a cosmic version of Lego. While all these features sound like sci-fi, mathematicians and physicists can describe them with real equations. The tricky part? We don't actually know if most of these weird space-time features exist in nature. For now, they live in the realm of mathematically possible and mind-blowingly cool. Let's get into the idea of a multiverse. Just imagine our universe, the one with galaxy stars and your neighbor's questionable taste in lawn gnomes, being nothing more than one bubble in a massive cosmic bubble bath. This is the idea behind the multiverse. The idea that our universe could be one of countless others, each with its own rules, constants, and maybe even weirdly different physics, is overwhelming. While cosmic inflation suggests space could have expanded in patches and created a bunch of bubble universes, string theory adds its own twist. It proposes a landscape of possible universes with different fundamental setups. On the other hand, quantum mechanics hints that every choice or random event could spawn a new universe. The theory is that somewhere out there, there's a version of you who slept like a baby last night and woke up to go to the gym and eat healthy. Kind of like the butterfly effect. Have you ever watched that movie? If not, you should. It is all theory and imagination, which makes it perfect material for Marvel movies. Think of Doctor Strange hopping through realities or the chaos of the multiverse in Avengers Endgame. Scientists are playing with the same ideas, just without all the CGI explosions. While it's a possibility, the multiverse is still very much a what if rather than a we know it's true. The multiverse is a super cool explanation for why our universe seems so perfectly tuned for life, but nobody's actually seen it in another one yet. Another question that has stumped scientists forever is whether or not there are higher dimensions. The world as we know it follows three directions: up and down, left and right, forward and backward. Then there's time, which we move through like a river. That's 4 dimensions. Easy peasy, right? Not so fast. String theory, however, suggests the universe could have 6 or 7 extra dimensions hidden away. Ones so tiny we can't see them. It's like a superpower with secret powers you can't see. The higher dimensions might be quietly shaping everything we experience without us even realizing it. These hidden dimensions could affect how everything from particles to gravity behaves. So does the universe have secret layers we can't directly detect? Right now, it's all just theoretical, since no one's actually measured them. But they're an important part of trying to fully understand how everything in the universe fits together. If we actually discovered them, scientists could finally unify all the forces of nature. In short, even though we don't experience them, higher dimensions could be quietly shaping the universe in ways we're only beginning to imagine. People all over the world have reported hearing loud, unexplained noises coming from the sky. Sometimes it's a deep boom that sounds like distant artillery. Other times it's more like a metallic trumpet echoing through the air. Scroll through enough social media feeds and you'll find recordings that would fit right into a Hollywood blockbuster. These events are called skyquakes, and they've been heard near coastlines, lakes, and even over major cities. The earliest account dates back to New Madrid, Missouri, where people reported thunderous blasts during an actual earthquake in the early 1800s. In New York, they're known as the Seneca guns. In Japan, they're called the uminari, cries from the sea. There's no single explanation. Scientists have blamed everything from shifting air pressure to underground gas bubbles to military aircraft, but nothing fully accounts for what people are hearing. If you blast a powerful sound wave through water, you'll get more than a ripple. Under the right conditions, it can trigger tiny bubbles that collapse and release a sudden flash of light. The entire event lasts just billionths of a second. The phenomenon is known as sonoluminescence, and it was first noticed in the 1930s when researchers were experimenting with sound in liquids. What you actually see is just a tiny flash, gone in an instant, but bright enough to make you wonder how a bubble could do that. Some researchers think the bubble gets so hot that it turns into glowing plasma. Others point to shockwaves or electrical sparks. Some have even gone so far as to try a link to fusion, but no one's confirmed it just yet. Almost every animal has eyes. Insects, mollusks, fish, mammals, and dozens of other groups all have them. Scientists think they started out as tiny light-sensitive spots that slowly became more complex over time. The trouble is that this didn't just happen once. Eyes seem to have evolved at least 40 different times in completely unrelated species. Things get even creepier if you look back to the Cambrian explosion around 540 million years ago. Fossils from that period already show creatures with fully formed eyes, complete with lenses and retinas. That's hard to explain, because an eye only works if every part develops together. One missing piece, and the whole organ is useless. It keeps surprising us to this day. Some deep-sea fish have eyes that work where there's almost no light at all. So the way eyes keep reinventing themselves is probably one of nature's biggest mysteries. The story of eyes shows us how fast evolution can move, but some creatures like horseshoe crabs, coelacanths, and a few shark species have also proven that it can stand completely still. These animals all look almost identical to their ancestors that lived hundreds of millions of years ago. The unusual explanation is stabilizing selection, where a body design is so effective that it doesn't really need a whole lot of tweaking. Yet that still leaves major questions. If other species were racing ahead, why didn't they leave ancient holdouts behind? What protected them from extinction while so many others disappeared? Some researchers think the answer might be hidden in subtle changes that don't fossilize, like shifts in chemistry or physiology. If that's true, these living fossils may not be as static as they seem. Figuring out where eyes came from is tough enough, but nothing compares to the strangeness of metamorphosis. A caterpillar doesn't just grow wings. It literally dissolves into a soup of cells inside its chrysalis and then rebuilds itself into a butterfly or moth. Somehow, it even manages to carry over memories from its caterpillar life into the adult stage. Tracing the history of butterflies and moths gives us part of the picture, but no transitional fossils explain how such a radical process developed step by step. One idea is that insects evolved separate life stages to avoid competing with themselves. Caterpillars eat leaves, adults sip nectar, so the two don't battle over food. Another theory points to ancient parasitic lifestyles, with early larvae living inside plants or hosts until adulthood. Whichever path it took, the fact that an animal can liquefy its body and come out functional on the other side is a very neat trick. Get on it, magicians. Come on, David Blaine. Do it. Liquefy yourself. The universe is full of surprises, and astrophysicists think there are still objects out there waiting to be discovered. Things we haven't seen yet, but could totally exist. Theories surrounding primordial black holes, quark stars, and rogue planets drifting alone are among just the few things scientists are hoping to find in space. On top of that, they believe the universe may be hiding ancient relics and leftover scars from the Big Bang. One of the biggest discoveries astrophysicists are hoping to make is magnetars. These are neutron stars with insanely strong magnetic fields. And even more wild and strange is the theory that there are neutron star variants that push physics as we know it to the limit. Thankfully, with the help of better telescopes, gravitational wave detectors, and high-energy observatories, more and more discoveries are being made each and every day. We're closer than ever to spotting these and other cosmic oddballs. In short, the cosmic zoo is far from complete, and the next discovery could be weirder than anything we've imagined. Did you know there's a planet considered a cosmic rebel? Well, that's Venus for you. This planet is truly strange. It spins the opposite way from most planets, which is whimsical and fun for sure, but it's also downright odd. Just picture the sun rising in the west and setting in the east. I can't handle sitting on a train backward, never mind standing on a planet spinning the wrong way. No thanks. How did it end up doing this? Well, as far as we can tell, it's all because of a series of dramatic events. Scientists believe that early on, Venus was slammed by massive collisions with other protoplanets, which flipped its spin. And on top of that, the sun's gravity may have slowly tugged on Venus for billions of years, gradually slowing it down and nudging it to spin backwards. Scientists aren't completely sure which factor played a bigger role in this happening, and some theories suggest it's a combination of both. As if that's not weird enough, Venus spins slowly, like unreasonably slow. 1 day on Venus is longer than a Venusian year. Venus is just that girl. She's quirky, dramatic, and mysterious. If the universe were fair, there should be just as much antimatter as matter. But like life, and that time your brother got 2 scoops of ice cream when you only got 1, it's not fair. Not fair at all. When matter and antimatter meet, they destroy each other in a flash of energy. If things had played out evenly, the early universe should have been one giant self-destruct button. Poof, nothing left but radiation. But clearly, we're here, so matter must have won by the tiniest of margins. For reasons we don't fully understand, the early universe played favorites and made just a little more matter than antimatter. The math says you only need about 1 extra particle of matter for every billion pairs that annihilate it, and that tiny imbalance was enough to build everything. Stars, galaxies, pizza, and us. The standard model of physics does explain some of this favoritism through something called CP violation, but it's not nearly enough to account for the amount of matter we see today. That's why scientists think there must be new physics at play. We don't have the full answer yet, but without that little cosmic cheating, the universe would be a very empty, very boring place. Now, I've talked plenty about black holes in this video, but there's still one more question that science has yet to answer. Do they have firewalls? No, not the type that you're thinking about that has you installing Norton antivirus. That program cannot help with these. The firewall theory is truly strange. Einstein believed that if you fell into a black hole, you wouldn't notice anything strange or weird around the edge. You'd simply drift across the event horizon peacefully, before getting crushed by lack of gravity. But the firewall theory says differently. It predicts that the edge is actually a raging wall of energy that instantly incinerates anything that tries to cross. Talk about false advertising. This idea comes from trying to make quantum mechanics and relativity play nice, especially when it comes to Hawking radiation and the infamous information paradox. A firewall would solve part of the puzzle, but it also breaks Einstein's rule that falling in should feel smooth. Right now, though, it's just a theory. A space theory. And no one's seen evidence of firewalls, and many physicists doubt they exist. Still, it's a wild possibility that makes black holes even scarier than they already are. Now for the biggest question of all. Are we alone in our universe? The honest answer is, we have no idea. Even just last year, the US government kinda sorta confirmed UFO sightings, which had everyone talking and wondering if they were also hiding aliens. Could it be that we're not the only intelligent life forms out there? Considering the size of the universe and the billions of galaxies, each holding billions of stars and even more planets, it feels hard to believe that we're the only ones out here. On top of that, we found organic molecules scattered all over space, which means the building blocks of life exist in the great unknown. If you just look at the side of our universe, or the billions of galaxies that hold billions upon billions of stars and planets, it's hard to believe we're alone out here. Knowing this, scientists are searching in all directions for signs of life. We haven't found microbial life on planets and moons in our solar system like Mars or Europa yet, but we're not giving up. Scientists all over the world are scanning the atmospheres of distant exoplanets for biosignatures. Projects like SETI are listening for any signals from intelligent civilizations. Despite decades of searching, we have yet to find definitive proof. That makes this one of science's greatest open mysteries. Life could be common and we just haven't discovered it yet. Or it could be vanishingly rare, making Earth incredibly special. Either way, the search continues. And if we ever do find the tiniest hint of life elsewhere, it'll be one of the biggest discoveries in human history. In 2020, astronomers in Australia scanning the skies with the ASKAP radio telescope picked up faint, ring-shaped signals that didn't look like anything they've ever seen before. These odd radio circles, or ORCs, are enormous, about 1 million light years across, and most appear to be centered on distant galaxies. The catch is that they don't show up in visible light or X-rays, only in radio waves. That makes them almost impossible to compare with anything else we've studied. In fact, we've only found about a handful so far, which makes the mystery even harder to crack. They could be anything from the aftermath of colossal explosions in galaxies or jets shooting out from black holes to giant shockwaves spreading through intergalactic space. Whales and dolphins never switch off completely. Instead of shutting down both sides of the brain when they go to sleep, they rest one hemisphere at a time. While one side rests, the other stays awake enough to guide them to the surface for air, keep them moving, and watch for predators. Birds like swifts and ducks can do this too, especially when they sleep mid-flight or in exposed areas. Why evolution favored this in some creatures and not others is still debated. For marine mammals, the logic seems clear enough. A dolphin that sleeps too deeply risks drowning. A whale that ignores its surroundings risks an ambush. But that only explains part of it. Fish live underwater all the time, yet they don't use this trick. Reptiles spend long stretches in risky environments, and they don't either. What's most difficult to explain is how they alternate between the halves so smoothly, resting one hemisphere at a time, yet keeping their movement, memory, and awareness intact. The muon is like the electron's bigger, bulkier cousin. Okay, try to bear with me. I know we're not all science buffs, but scientists know exactly how it should behave thanks to their best rulebook for particles, the Standard Model. That rulebook can predict the muon's wobble in a magnetic field down to absurd accuracy. But when researchers actually measured it, first in 2001 and again in 2021, the numbers didn't match. The muon was wobbling more than it should. That tiny difference has huge implications. It could mean that there are hidden forces or unknown particles pushing on the muon, something completely outside of what we know. On the other hand, it might just mean our calculations of the rulebook need fixing. Either way, the strange result refuses to be explained away. You wouldn't expect to find mummies in a rainforest. The constant humidity should rot a body in weeks. Yet the Anga people of Papua New Guinea developed a method that somehow preserved their dead for decades. Instead of drying them with salts, like in Egypt, the Anga placed bodies above a fire, cut them open at the joints, and drained the fluids. Once dried, the mummies were left perched on cliffs, where some are still visible today. What science can't explain is how they lasted. Heat and smoke should slow decay, but in a tropical climate, the preservation should have failed long ago. The Anga themselves no longer remember the origins of the ritual, and the only descriptions come from early outsiders whose accounts may not be reliable. Barro Colorado Island in Panama should be a paradise for wildlife. At one point, over 200 bird species lived there. Yet, in just 100 years, a quarter of them have completely disappeared, and no one knows why. The mystery started after the Panama Canal was finished in 1914. Rising waters turned the surrounding valleys into part of Gatun Lake, resulting in the island. Some thought the change helped monkeys and quaddies thrive, wiping out birds by raiding their nests. But cameras later showed the real culprits were snakes, which had quietly been eating eggs all along. But still, even snakes couldn't explain the scale of the collapse. By 2000, 45 species were simply gone. They weren't migrating elsewhere, they weren't being replaced, and the ecosystem offered no obvious explanation. Their disappearance is something our best and brightest are simply struggling to comprehend. For this one, we're traveling all the way to the gorgeous island of Hawaii. Lush greenery, stunning ocean views, and awe-inspiring native stories and culture are the heart of Hawaii, but it's not all lays and hula. There's something truly terrifying that happens at the mouth of the volcano. It seems lava is a bit more unnerving than you may think. Not only does the lava bubble and boil under the surface, but when airborne and lava droplets meet up with the wind, something disturbing happens that could have you running scared. The wind takes those fiery droplets and stretches them out to resemble long, thin strands of human hair. Sounds cool, right? It is. But it's also kind of scary. Locals call these delicate fibers Pele's hair, after the Hawaiian goddess of volcanoes. You can see this phenomenon happen in areas like Hawaii Volcanoes National Park, but don't get too close and definitely do not touch them. They may look like something out of a high fae story, but they're hazardous to say the least. Because, it's literally lava. Have you ever heard of blue jets and red sprites? No? Well, let me tell you all about them. These are two types of transient luminous events, which are optical phenomena that occur in the upper atmosphere. These happen above thunderstorms and are triggered by lightning discharges. The red sprites are large red-orange glowing bursts with tendrils following behind. Sounds pretty magical, right? As for those blue jets, those are cone-shaped streamers that shoot upward from a thundercloud. These are rare sights for those of us here on the ground, but they aren't uncommon to witness if you're living on the space station. In 2017, scientists aboard the station witnessed 245 blue flashes in 160 seconds during one storm. While that sounds amazing to see, it's not so easy to study since each flash lasts just tens of milliseconds. Who doesn't love a good rainbow? And even better is when you catch the rare double rainbow, but even rarer is if you catch a glimpse of the elusive fire rainbow. Yeah, I said fire rainbow. Despite the name, fire rainbows aren't actually rainbows or fire, but a rare phenomenon called the circumhorizontal arc. These bands of light that streak across the sky are often mistaken for rainbow clouds or flames, but are really just the effect of sunlight entering high-altitude cirrus clouds made of ice crystals. When light hits them at the exact right angle, a fire rainbow occurs. For this to happen, the sun has to be at least 58 degrees above the horizon, and the ice crystals have to be horizontally aligned so they can act as tiny prisms. The result is something straight out of a fantasy novel, and makes the clouds look like they're on fire. The Hesdalen lights appear as free-floating glowing orbs of various colors and shapes. They were first spotted in rural Norway in the 30s, and theories around their origin vary greatly. Some scientists believe they are an atmospheric phenomenon made up of ionized gas or plasma. Others theorize that they're the effect of piezoelectricity in quartz-rich rocks. Either way, their origin remains a complete mystery, as does the exact mechanism that causes these orbs. Have you ever sat on the grass watching the clouds? It's fun to find super cool ones shaped like dinosaurs and elephants. What's more fun is traveling to Antarctica or northern Scandinavia and cloud watching there, because you might see a sight that'll have your jaw on the floor. In this part of the world, you can catch a glimpse of polar stratospheric clouds, termed nacreous clouds. These aren't just your regular fluffy white cotton balls in the sky. These clouds are rare and form during the extreme cold of polar winter when the temperature drops below negative 78 degrees Celsius. During these wickedly cold temps, water vapor and nitric acid condense into ice particles, which develop far above the weather layer of the atmosphere. What makes these clouds extra special is that when the sunlight hits them, they scatter their beautiful iridescent colors across the sky during the twilight hours in stunning pastel hues of green, purple, pink, and gold, often resembling mother of pearl. Right out the gate, yes, we found something on Venus that made scientists sit up straight. In 2020, a research team spotted phosphine gas high in the planet's clouds. Here on Earth, phosphine usually comes from microbes or certain industrial processes, so finding it in a place as hostile as Venus was a shock. Temperatures there are hot enough to melt lead, and the atmosphere is full of sulfuric acid. Even so, the signal suggested about 20 parts per billion of phosphine, and there's simply no obvious non-living way to make that much gas in those conditions. Other scientists, however, challenged the results and came up with a few other ways the gas could have formed, like volcanic emissions or lightning. So at this point, it boils down to figuring out if we found microbes or just uncovered another Venus mystery. In 2014, satellites caught something strange swirling over the North Pole. It looked a lot like a hurricane, but it was hundreds of miles up in Earth's upper atmosphere, and instead of clouds and rain, it was made of plasma. Back then, nobody knew exactly what they were seeing. Years later in 2021, scientists went through the data and confirmed that it was a space hurricane, a 600-mile-wide cyclone of charged particles rotating counterclockwise, with a calm center and spiral arms raining electrons into the ionosphere. It lasted almost 8 hours before breaking apart. This was the first time anything like it had been observed, and it showed that under the right conditions, solar wind and Earth's magnetic field can whip up hurricane-like storms deep in space. In 2019, NASA's Juno spacecraft spotted something unusual flickering high above Jupiter's storms. These weren't the planet's usual lightning bolts. They were millisecond-long bursts of light in the upper atmosphere, similar to the sprites and elves we see above thunderstorms on Earth. On our planet, sprites and elves look like glowing red jellyfish-shaped flashes triggered by lightning. But Jupiter's atmosphere is rich in hydrogen, so its versions glow blue instead. We caught about a dozen of these flashes near the poles, right where auroras ripple through the planet's skies. The discovery confirmed a long-standing prediction that upper atmospheric lightning could take place on the so-called gas giants, and suggested that these bursts could be more common on other planets than we ever realized. Astronomers got a shock in 2021 when they uncovered the largest haul of rogue planets ever seen. At least 70 drifting through space with no star to call home. Each is roughly the size of Jupiter, and they were spotted in a star-forming region in Upper Scorpius, about 420 light-years away. Because rogue planets travel in darkness, the team detected them by their faint heat glow. These worlds are only a few million years old, still warm from their formation, and visible in infrared light. The find came from combing through 20 years of data from several observatories, looking for the specific colors and motions of planet mass objects. The sheer number in this cluster suggests the Milky Way could be packed with billions of them. Some may be failed stars. Others may have been ejected from their home systems. Either way, they are the true drifters of the galaxy. When astronomers turned South Africa's Meerkat radio telescope toward the galactic center, they discovered hundreds of needle-thin structures stretching through space like strings on a harp. In total, these filaments cover more than 30 times the size of the moon and extend up to 100 light-years in length, but only a fraction of that in width. About 1,000 have now been cataloged, all concentrated near our galaxy's central black hole. No one is sure what they are. They might be giant magnetic structures lit up by energetic particles, or the shockwaves of past star explosions. We've never seen them in such detail before because no previous telescope could produce a radio map this sharp over such a wide area. Since Meerkat's breakthrough, though, astronomers have been following up to see if these strange threads shift or change over time. When the James Webb Space Telescope turned its eye to the galaxy cluster SMACS 0723, the result was incredible. In just 12.5 hours of infrared exposure, it captured thousands of galaxies packed into a patch of sky no bigger than a grain of sand held at arm's length. If you look at the picture, you'll see that some of the galaxies in the image look stretched or curved into delicate arcs. That's gravitational lensing at work. The massive cluster in the foreground is bending and magnifying the light from galaxies far behind it, including some that formed less than 1 billion years after the Big Bang. We had never seen the distant universe in this much detail this quickly, and it was only Webb's first public image. Researchers are still mining the image for galaxies at the farthest reaches of the universe. Let's talk about another super cool cloud formation that's also awe-inspiring: the Kelvin-Helmholtz clouds. These form when two layers of air with different speeds and densities move past each other. When this happens, the clouds form in a pattern that looks like ocean waves breaking across the sky. You'll find these most often around jet streams, mountain ranges, and weather fronts where strong winds are common. Unfortunately, they only last for a few minutes, so don't blink when they form or you might miss them. What's even more interesting is that this is also the same way actual ocean waves are created. Just not in the sky. Have you ever gotten up before dawn to watch the sunrise? If so, you may have noticed the upper edge of the sun flashing green. No, it's not the Flying Dutchman. This is called the green flash, and it's actually quite rare to see. It happens because the Earth's atmosphere bends sunlight and splits it into different colors like a prism. As the sun dips down below the horizon, the shorter wavelengths that are blue and green are bent more than the longer ones that appear red and orange. The blue light is scattered by the atmosphere, and under the right conditions, the green light lingers for a second or two, causing the green flash. Or it could just be Will Turner coming back to land for the first time in 10 years, so that too. It's probably that. Speaking of more clouds, we can't talk about them without also touching on the mammatus clouds. Named after the Latin word for mama or udder due to their appearance, they form from sinking air, which is the complete opposite of how other clouds are formed. These formations hang from the underside of the clouds, especially thunderstorm clouds, so you'll most often see them during severe storms. While harmless, their presence is an indication that the weather conditions are truly terrible. You may want to stay inside and have a pajama day when they come rolling around. To talk about our next bizarre fact, we have to travel to Yosemite National Park to check out Horsetail Fall. This waterfall is stunning on a good day, but for 2 weeks a year in mid to late February, it becomes a spectacular firefall. Yes, a firefall. This happens when the setting sun illuminates the falls during the snowmelt and turns the water from the crystal clear stream we're used to seeing to a brilliant orange-red tone. If you're planning a trip to the park, book it around that time, because this is definitely a sight you'll want to see. It sounds fire, right? Right? See what I did there? No? Okay. Speaking of nature taking regular things and turning them into liquid fire, we're heading over to the Mekong River in Nong Khai, Thailand. Each year around October, at the end of Buddhist Lent, locals head to the river to check out the Naga Fireball Festival. It's one of the country's most intriguing celebrations. Locals and tourists sit on the edge of the river to watch glowing orbs arising naturally from the river and ascend into the air. These Naga fireballs can be quite big, sometimes the size of a basketball, and they can shoot up as high as 600 feet into the air. According to the lore, Nagas are shapeshifters as described in Jainism, Buddhism, and Hinduism. In Thai folklore, they can take any shape they want, from human form to a serpent and everything in between. Scientists, however, claim that they're nothing but burning methane gas. Either way, it's still quite a sight to see, and should be on everyone's bucket list. I've talked about things floating up from the water, but what about the scary things that are under the surface? And on this channel, I've talked about sea monsters, underwater black holes, and shipwrecks, but have you heard of a brinacle? No? Well then, allow me to give you another reason not to go deep sea diving. A brinacle is called the ice finger of death, and yes, it is deadly. So deadly, in fact, It turns everything it touches into ice. Is it Marvel's Iceman of the Sea? Sure, we can call it that. Or maybe like Ice Medusa or Ice Midas. Either way, it's actually really scary. Brinicles form beneath the sea ice in the polar region. It happens when salty brine expelled from the sea is supercooled. The brine is denser than the water around it, so it sinks, and as it descends, it freezes the seawater surrounding it. This creates a hollow tube of ice that's so frigid it literally freezes anything it comes into contact with. I mean, imagine being a starfish or a sea urchin just out there minding your own business, and this weird sea icicle thing just touches you, and now you're encased in ice. Nature is truly a wild ride. You've probably seen this photo before. In 2022, we finally got it. The first picture of Sagittarius A, the supermassive black hole at the center of our galaxy. It took a global network of radio telescopes working together as the Event Horizon telescope to pull it off. The result was a glowing ring of distorted light wrapped around a dark central shadow created by gravity so strong that not even light can escape. Sagittarius A is about 4 million times the mass of the Sun, yet it looks very similar to the black hole in galaxy M87, showing that the same physics holds true across very different sizes. And while we've known it's there for several years, capturing it was like taking a photo of a bagel on the moon from Earth. It finally gave us a face to put to the Milky Way's black heart. W Orionis is not your typical star system. It has 3 young stars, all tilted at odd angles to each other, and their combined gravity has done something dramatic to the planet-forming disk around them. Instead of a single flat sheet of dust and gas, the disk has been torn into separate misaligned rings with a clear gap between them. Our first glimpse of it was in 2020, thanks to observations with the Very Large Telescope in ALMA. The images showed one inner ring sharply out of line with the outer disk, confirming that multiple stars can physically warp and split a disk apart. It is one of the clearest looks we have ever had at how unstable young solar systems can be. On October 9th, 2022, our space telescopes caught something so intense it literally maxed out their detectors. It was a gamma ray burst, later nicknamed the Boat, the brightest of all time, and astronomers believe it might have been the most powerful one in human history. Gamma ray bursts are already among the most energetic explosions in the universe. I mean, look at it, they even create Hulk. But this one was about 70 times brighter than anything seen before. Astronomers believe that it might have been caused by a massive star collapsing into a black hole, sending 2 narrow jets of energy almost directly toward Earth. The blast was so powerful that it lit up detectors across the spectrum, with an afterglow that lasted for weeks. Since I'm on the subject of very bright things, Proxima Centauri, our closest stellar neighbor, showed its temper in 2019 with a record-breaking stellar flare. In just 7 seconds, the star's ultraviolet light output jumped to about 14,000 times its normal level. The blast was approximately 100 times more energetic than the largest solar flare we've ever seen from our sun, and in all probability, stripped the atmosphere from its nearby planets. Luckily, by the time that energy reached us, it was far too weak to have any impact. It was caught during a 40-hour observation campaign using multiple telescopes, including Hubble and ALMA, making it the most extreme flare ever recorded from Proxima. For astronomers, it was a rare chance to measure just how quickly such a small star can unleash so much energy, and to calculate the risks they pose to the worlds that might otherwise seem habitable. In 2021, astronomers got their first clear view of a moon-forming disk around a planet outside our solar system. The ALMA observatory spotted a wide ring of gas and dust encircling PDS 70c, a young Jupiter-like planet about 370 light-years away. The disk is roughly the size of the distance between Earth and the Sun and holds enough material to form several moons. PDS 70c happens to sit inside a larger protoplanetary system that contains another giant planet, PDS 70b, and the two share the same disk of material. So, we now know that planets can sustain their own disks of material similar to the one that built Jupiter's moons, and scientists got to see a working example of a moon-building factory in another star system. Just in case you don't know, Spaghettification is what happens when an object gets pulled into a black hole's gravity and is stretched into a long, thin strand. The name paints a pretty clear picture. Scientists have known about the process for decades, but it's rare to catch it happening in real time. A star that met this fate was recorded in 2019 in one of the best observations yet. The event, nicknamed Death by Spaghettification, I know, talk about being creative, occurred when a star drifted too close to a supermassive black hole about 215 million light-years away. Its material was pulled into narrow streams, flaring brightly as some spiraled in and some were ejected outward. The flare and debris told the whole story, from the first rip to the star's complete destruction. Long before we got that first glimpse of the Milky Way's black hole, Sagittarius A, in 2022, the Event Horizon Telescope had already delivered another historic first. The first photo of M87, a supermassive black hole 55 million light-years away. That orange, fuzzy donut became one of the most famous space images ever taken, but it was hiding a finer detail no one had spotted before. In 2022, researchers reanalyzed the original data and stripped away the glare from surrounding material. Beneath it all was a razor-thin photon ring formed by light looping around the black hole's gravity well multiple times before escaping. The same work also revealed the footprint of a powerful jet erupting from M87, driven by matter spiraling toward the event horizon. Fast radio bursts are already quite mysterious. They're millisecond-long blasts of radio waves from deep space, some coming from magnetized neutron stars, others from dwarf galaxies, and some from environments scientists still can't explain. But in 2020, one source went completely over the top. FRB 121102, sitting in a dwarf galaxy about 3 billion light-years away, fired 1,652 bursts in just 47 days, sometimes over 100 in a single hour. More than every other known FRB combined in the same period. China's FAST telescope later revealed that this repeater follows a 157-day cycle of activity. If it's a magnetar, that means something the size of a city is hammering out more cosmic signals in a few weeks than every other known source in the universe. It took 8 years to confirm, but in 2022, the US Space Command officially announced that a fireball over Papua New Guinea in January 2014 came from outside our solar system. The half-meter-wide meteor, traveling at more than 60 kilometers per second, was the first confirmed interstellar object to visit Earth, beating Oumuamua, the cigar-shaped visitor spotted in 2017, to the title. This one, though, didn't just pass us by, and the find kicked off a scientific tug-of-war. The Galileo project launched an expedition to recover fragments from the ocean floor, and later reported that they recovered tiny spherules with unusual, possibly extrasolar chemistry. But everyone ended up fighting over the data and its credibility. If the analysis holds up, they could be the first evidence we've ever had of real interstellar material. It began with a ripple in space-time that lasted less than a second, but when LIGO and Virgo traced it back, they found it came from two massive black holes, one about 85 times the sun's mass, and the other around 66, that slammed together. The collision created a new black hole weighing in at 142 solar masses, which puts it in the long hypothesized middle ground between small stellar black holes and supermassive ones. The bigger surprise, however, was that the 85 solar mass black hole should not have existed in the first place, at least not from a single star's collapse. So scientists now believe that this single flash of gravitational waves may have captured not just one, but two generations of black hole collisions, almost like a family tree in space-time. Speaking of brine, are you aware that there are brine pools that form underwater lakes? Yeah, a lake literally under the ocean. These dense bodies of water are found in depressions below the polar ice sea. They form as the seawater dissolves ancient deposits and creates a supersaline body of water that sinks to the ocean floor. On top of being a lake inside an ocean, they're highly toxic due to carrying a high concentration of chemicals like methane and hydrogen sulfide, which are lethal to most marine life. However, they also form unique ecosystems along their edges, so deadly and vital. Nice. That's not contradictory at all. Oh, I'm sorry, did you think brinicles are scary sounding? Well, just wait until I tell you all about hair ice. This is a super rare and super delicate occurrence that happens when fine, silky filaments of ice are formed on dead wood during cold, humid conditions. You find these hairs in forests as ice grows thin. Some of these ice hairs can reach up to 20 centimeters in length and truly do resemble white hair or spun sugarcane. This isn't like frost. These fragile threads are a production of moisture inside decaying wood that's infected with the fungus Exodopius effusa. As the fungus is drawn out through the wood's pores and hits the cold air, this is the result. The fungus helps the freezing process and prevents water from forming a solid mass of ice chunks, so the ice has no choice but to form hairs instead. Also, unlike frost, hair tends to retain its shape for hours, unless something touches it. Any contact will cause them to completely fall apart. We've all heard of permafrost. Places like Siberia are famous for being so incredibly freezing that it truly is a frozen tundra in places. But did you know permafrost can explode? Oh, terrifying. Giant permafrost explosions happen when methane gas is released and forms large craters. This was first observed over 10 years ago in the Yamal Peninsula. Scientists discovered this shocking occurrence in 2014 and have since determined that this is a massive consequence of climate change. The warming of the Earth's surface is causing permafrost to thaw, which is destabilizing methane hydrates and salty cryopes. This rapid decrease in pressure and increase in temperature triggers the release of methane gas, which then explodes and leaves behind craters. One of the creepiest natural events you'll see quite often is St. Elmo's fire. It's not really a fire, though. It's a glowing blue or purple light that shows up on pointy objects during thunderstorms like church steeples, aircraft wings, and ship masts. It happens when the air is so full of electrical energy that it makes the air around the tips of tall, pointy objects appear to glow due to air molecules ionizing and emitting the glowy light. And not just glowing, but buzzing. People have reported hearing a cracking or hissing sound that accompanies the fire. Imagine seeing that at a church during a full moon. Now that would definitely seem like something out of a horror movie. St. Elmo's fire. Good song. We've all watched footage of tornadoes ripping through towns and destroying everything in their path. It's super scary, especially when the destruction is extreme. What's even scarier, though, is a waterspout. It's basically a tornado, but over water. This funnel-like cloud reaches down from the sky to touch down on the water's surface. And now, there are two types. The weaker of the two is the fair weather waterspout, and less dangerous and doesn't really last long. However, waterspouts are just as dangerous as land tornadoes. They can flip larger boats, damage ships, and if they reach land, watch out. They will tear up houses, buildings, and power lines just as harshly as the ones you see on the news. A supernova is one of the most violent events in the universe, a star-ending explosion that can outshine entire galaxies. A nova is smaller, but still massive, triggered when a white dwarf pulls in enough material from a companion star to ignite a global surface explosion. In 2022, astronomers announced something even smaller, a micronova. These are localized thermonuclear bursts that only erupt at a white dwarf's magnetic poles. The star's powerful magnetic field funnels hydrogen into small regions where it rapidly fuses, releasing unimaginable amounts of energy in just a few hours. One micronova can burn through 20 trillion kilograms of material, the mass of billions of Great Pyramids of Giza. Astronomers spotted 3 of them in NASA's test satellite data and confirmed the find with the Very Large Telescope. The VLT sits in Chile's Atacama Desert and is one of the most advanced optical telescopes on Earth, making it perfect for catching these blink and you'll miss them type blasts. The Hubble Space Telescope set a distance record in 2022 when it found the star Earendel, nearly 13 billion light-years away. That's so far away that we're seeing it as it was just 900 million years after the Big Bang. The only reason Hubble could spot a single star at such an extreme distance is because of gravitational lensing. In this case, a massive galaxy cluster between us and Earendel bent and magnified its light thousands of times, stretching it into a long arc in the image. Arundel is believed to be 50 to 100 times the sun's mass and millions of times brighter. Scientists believe it might actually belong to one of the earliest generations of stars ever formed, when heavier elements were rare. In late 2019, early 2020, skywatchers noticed something odd in Orion. Betelgeuse, the bright red supergiant making the Hunter's shoulder, had dimmed by nearly 60%. This great dimming was so dramatic that even casual stargazers could see the change. Astronomers raced to figure out what was happening. Observations from the Very Large Telescope showed the star's southern hemisphere looking darker and oddly lopsided. NASA's Hubble later revealed that Betelgeuse had essentially blown its top. It ejected part of its surface into space, and that material cooled into a massive dust cloud that blocked its light from reaching us. The explosion had over 40 billion times the material of a solar flare, making it a one-of-a-kind event in astronomy. When the James Webb Space Telescope turned its eye towards HIP 65426b in 2022, it caught something we had never seen through its lens before: a planet outside our solar system. This one is a young gas giant, several times larger than Jupiter. Webb spotted it so far from its star that the telescope could block the glare and capture the planet itself, something only the most advanced coronagraphs can pull off. The result looks like a small bright smudge, but that smudge is proof that Webb can directly photograph worlds trillions of miles away. Since that first capture, 3 years ago at the time of this recording, astronomers have been processing the data to sharpen the image and extract more details about the planet's atmosphere and temperature. Another natural phenomenon that shouldn't really exist is virga. This is when rain or snow starts falling from a cloud but never actually reaches the ground, and instead vanishes on its way down. Virga often looks like faint streaks or wisps hanging from the bottom of a cloud, almost like a thin tail. This happens when rain or snow comes into contact with warm air on its way down and begins to evaporate mid-air. This is most common in places with desert lands and is a big concern for pilots because it means strong air currents are happening in the sky. This invisible rain can cause a microburst of strong blasts of wind that hit the ground and spread in all directions, making landing a plane even more difficult than it already is. Now let's get into the belt of Venus. This is the pink glow you can sometimes see in the sky just after sunset or before sunrise. You'll notice it just a little above the horizon. This happens when the sun goes down and the Earth's shadow starts rising in the sky as a dark bluish band. Above that shadow, the leftover light scatters in the atmosphere and turns the sky a rosy color. You'll be able to experience this best if you're looking at the sky when it's clear and you have a wide view, such as over the ocean, in a desert, or over the mountains. If you thought the most beautiful shiny objects you would ever see are inside a jewelry store, well, think again. Let me introduce you to Hokkaido, Japan, where the beach literally sparkles like a diamond. Locals in the area call it jewelry ice, which actually is the perfect name for this phenomenon. How does it happen, you may ask? Well, in the winter, chunks of ice break off from the Tokachi River and make their way floating into the Pacific Ocean. When the waves toss them around for a bit, the ice gets smoothed out and starts looking an awful lot like giant see-through crystals. Then they wash up on Otsu Beach and scatter across the sand like a display case that Mother Nature set up herself. Adding to this is how the ice gems catch the light. During sunrise, they glow orange and gold, as if someone dumped a treasure chest on shore. As the hours tick by, they turn glassy and clear and appear like oversized diamonds. As you might expect, the weather needs to be just right for this to go down. So, if you want to add this to your bucket list, you need to book your trip between mid-January to late February. Just don't try to put one of those diamonds on as a ring unless you like having really cold fingers. Damn, that's when I was in Japan, but I was up in Tokyo. I didn't go to Hokkaido. I missed it. If you thought sand was just for beaches, think again. In Tokushima, Japan, things get rather ambitious in this department. If you travel over to the Awa sand pillars, you'll see a whole host of giant sand towers that look oddly like the ruins of a lost city. Over tens of thousands of years, layers of sand and volcanic ash mixed together and were slowly carved by wind and rain. The softer sand washed away, and the hard bits stayed put and formed these tall pillars. Walking amongst them can feel a bit like wandering through a mysterious ancient world. Honestly, it's hard not to be impressed when something as simple as sand can pull off these kind of dramatics. After years and years of searching, Hubble finally spotted the first confirmed rogue black hole in 2022. This one sits about 5,000 light years away, weighs in at roughly 7 suns, and is far too big to be a neutron star. Since it gives off no light, the only way to see it was to watch what it did to the space around it. As it moved in front of a distant star, its gravity bent and amplified the star's light in a process called microlensing. The brightening lasted more than 270 days, much longer than a normal lensing event, which confirmed the culprit was massive and invisible. Researchers think that it might have formed after a supernova kicked it clear out of its home system, leaving it to float across the galaxy. In 2020, astronomers caught a massive star in the act of dying. The red supergiant, about 10 times the sun's mass and sitting in the galaxy NGC 5731, suddenly started shooting out huge amounts of gas and light. It pulsed like that for 130 days before finally collapsing in a spectacular supernova. Because astronomers had already spotted the warning signal, telescopes like Keck were locked on and ready when the star finally blew. What they saw was the explosion smashing straight into a thick cloud of gas the star had coughed out only months before. Until then, the thinking was that red supergiants spent their last days in silence. This one, however, went out kicking and screaming, rewriting the science on a star's final moments. Now, I've already told you about the discovery of Sagittarius A, our very own black hole at the center of the Milky Way, and you can bet astronomers keep a close eye on it. So when it suddenly flared in 2019, it definitely got everyone's attention. For a few hours that May, it shone 75 times brighter than usual. So bright, in fact, that it was the most intense glow seen from it in 24 years of watching. The Keck telescope team even mistook it for a star at first. It was that bright. The leading theory is that it had just swallowed something, maybe gas from a passing cloud or even a piece of a star. The flare didn't last, but it gave scientists a rare front-row look at how our black hole can spring to life without warning. When we spotted that meteor from another star system in 2014, it kicked off a fight over the data. The second time, Oumuamua, the strange cigar-shaped object, refused to behave like anything we'd seen before. But in 2019, 2I Borisov finally gave astronomers a cooperative interstellar visitor, an actual comet they could study. Discovered by amateur Gennady Borisov, it came screaming in from deep space, trailing gas and dust like it was straight out of a science textbook. Hubble zoomed in on it and found a bright core wrapped in a halo with chemical signatures suggesting it formed on the frozen edges of a red dwarf system. By the time it passed twice as far from the sun as Earth is, it was already heading back into the dark, leaving us with the first clear picture of what a comet from another star really looks like. In early 2020, Comet Atlas was being hyped as the year's can't-miss space event, visible from your backyard. Instead, it pulled a disappearing act. By that April, Hubble was watching it disintegrate into more than 24 pieces, scattering along its path. Over just a few days, the fragments shifted and faded like lights winking on and off, as some evaporated into space. This kind of large-scale breakup is rare, only happening once or twice a decade. So catching it in real time gave scientists a peek inside the comet's structure as fresh ice and dust spilled out. Atlas never made its solar flyby, but it left us with a sky scene odd enough to fit perfectly into that unpredictable year. Have you ever heard of a mountain laying eggs? It sounds like something out of a sci-fi movie featuring a giant chicken, but it's definitely not, and it's definitely real. There is a cliff in Guizhou, China, that produces huge round stone eggs that weigh hundreds of pounds. Researchers claim they are formed from tiny particles like silicon dioxide that slowly clump together over millions of years. As the softer rock around them erodes, the giant rocky orbs stay and create nature's own slow-motion magic trick. These stone eggs aren't just cool to look at, they're sacred. To locals, they symbolize luck and protection. Generations of families pass them down and tell stories about them. My house growing up, I just had a bunch of rotten oranges from our orange tree. They'd fall sometimes, so definitely didn't pass those down to my Are you aware that there's a waterfall that can go from full-on Niagara Falls mode to almost nothing at all? That's exactly what the Boka waterfall in Slovenia is like. Nestled in the Julian Alps near the Socha River, this waterfall has two very dramatic stages. The first is the upper falls that plunge about 106 meters, and the lower one that adds another 33. What makes this fall weird, though, is how it literally ebbs and flows. The waterfall is fed by an underground spring, which makes it at the total mercy of the weather. When it rains, or there's a heavy snowmelt, you can expect the water to be rushing down. However, during the dry season, it's merely a tiny trickle at best, sometimes completely disappearing. One moment you're staring at a torrent, and the next, there's nothing. Nada. Boka is the perfect reminder that nature really can keep you guessing. If you ever do get a chance to visit Slovenia, make sure to check out these falls more than once on your trip, because chances are, it'll look quite different each day. Ever heard of a lake with moving islands? Look no further than Loktak Lake in Manipur, India. No, this isn't a video game. This is real, and it's actually amazing. Manipur is home to floating islands called pumdis, which are thick mats of plants and soil that just float. It's nature's giant version of a drifting lily pad. The biggest of the bunch is especially famous because it's home to the Kaibu Lamjau National Park. Imagine going for a day of sun and playing in a literal free-moving water park. And not only does it host the world's only floating park, it's home to an endangered species. Here, you'll find the brow-antlered deer, which prefer life on the water to life on solid land. Want to avoid going for a swim and getting boiled alive? Yeah, you'll definitely want to avoid going to nature's giant tea kettle located in Mont Trois Pitons National Park in Dominica. This stunning lake is about 60 meters long and is surrounded by steep cliffs and gorgeous views. But make sure you're only there for the views. These waters won't just warm your heart, they will scald you. Its surface is constantly churning and steaming. That's because this latte sits atop a volcanic vent called a flooded fumarole. The cracks in the Earth's crust allow extremely hot gases to escape, and rainwater and groundwater seep in to meet that heat. The magma that is beneath the island cranks the temperatures to a near boiling point, up to 92 degrees Celsius. That's hot enough to cook an egg. And your skin. Adding to the intrigue is the ghastly gray-blue color us millennials know and love. Don't be fooled though. It is not inviting you in. It's terrifying, and you shouldn't even try to dip your toe into this pool. Have you ever looked at water so blue it belongs in a movie about magic? If you haven't, you may want to add a trip to the Hinatuan Enchanted River in the Philippines to your bucket list. Nestled in Mindanao, this river is famous for its insanely clear waters that look sapphire blue and seem to almost glow all on their own. The water is so clear that fish look like they're floating mid-air. Local legend says these fish are supernatural guardians, which may actually be right, since they've never been caught by fishermen, despite a whole lot of effort over the years. And the gorgeous color isn't even the coolest part. Despite divers going as deep as 80 meters into its caves, they have yet to reach the bottom. Nobody knows how deep this river is. If you do take a trip there, make sure to check out the daily ritual known as the Hymn of the Enchanted River. Music plays while you feed the fish, and it's one of the most mystical experiences you can witness. It's beautiful, it's bizarre, and it's impossible not to get caught up in its natural magic. And that's it for today. But stop right there. Before you head out, let's test your memory real quick. In what month do zombie fires usually make their eerie return in the Arctic? Is it A, February, B, May, C, July, or D, October? Leave your answers down below. And you know what? While you're there, tell me which of today's strange cases you think deserves a list all its own. And if today's list left you wanting more of science's stranger side, well then you will love our related video. 25 times scientists created astonishing new states of matter. We covered a liquid that crawls up walls, a crystal that refuses to follow time, and even a form of matter scientists think could have come from another dimension. That link will pop up right here any second now. And as always, thank you guys so much for watching. Like, share, comment, subscribe, do all that as mentioned earlier, and I'll catch you next time. See ya.